Hello. We are moving on and we're going to do our next section of material, which is called graphs and lines. And in order for us to do that, we have to get a couple of formulas going today. First, let's look at the standard form of a line, just so we know what one of them looks like. It's ax plus by equals c. And you'll see this probably somewhere in your book. And the important thing to know is that A, B, and C are, for our case, real numbers. If you were to get into some complex algebra kind of stuff, you could have imaginary numbers. But for our purposes, we're looking at real numbers here. Okay, so you're going to have some stuff like um, 3x plus 2y equals 6. Okay. The thing to know about these is normally there are two variables. These are things that we can graph on a grid. Okay. So an XY coordinate plane, you've seen those probably. Okay. And you see here the 3, the 2, and the 6, those are real numbers. Okay. The X and the Y are variables. And unless I plug in a number to substitute for one of those variables, they're going to stay variables. Okay. So you're going to have stuff in this section where they ask you in the homework, where they ask stuff like, is the point 4, 3 a solution for this equation? Okay, so I've got an equation of a line. I know it's an equation of a line because here I've got x to the first and I've got y to the first. Okay, when both of those variables are ones, we consider it linear or a line. Okay, so is 4, 3 a solution? Remember that all of your coordinated pairs, or points as we like to call them, come in that form x comma y. So what they're saying is, can you plug in to this function, or this equation, I'm sorry. Can you plug into this equation 3, put in a 4 for the x, plus 2, put in a 3 for the y, equals 6. So they want me to know, or they want me to tell them, is that a true statement or not, basically. Okay. When they say, is it a solution, they mean, is this a true statement? So is this really equal? That's what we're trying to figure out. Okay. Sorry, my pen's trying to die on me there. Okay, so I am going to do the math. Okay, 3 times 4 is 12, plus 6 is 16. I'm sorry, is 6. That's what they're asking me. And again, there's like a question mark here. Is this true? And hopefully in your head, you're going, well, no, if it was a subtraction, we'd be okay. But that's 18 equals 6. Is that true? Okay, no, that's not true. Okay, so we put a not equal to here. Okay, and we say no. And so therefore, if it's not a true statement, then it's not a solution. Okay, so a chunk of what we're going to do in this particular portion of the course is we're going to be trying to find things that are solutions, which will make that equal sign be true, so that it's a true statement. Okay, but here we're saying no, 18 doesn't equal 6. That's just not true. So we're going to move on. Okay, that's not going to work. Okay. So instead, we're going to say stuff like, oh, well, if I want points that do work, can I get a couple of solutions? So two of the very easy ones for us to find are x-intercepts. I'm going to do this like this, and y-intercepts. So I'll do one on the left and I'll do one on the right. Okay. So think about it. If it's an x-intercept, let me come back up here and give just a little bit. I said about the xy coordinate system, right? Okay. So if something's an x-intercept, that means it's crossing the x-axis. Maybe it crosses here or something. If it crosses right there, then what we see is there's an x value, positive, negative. It could be 0, but the y value for sure is 0. right? For it to cross the x-axis, it's not a positive y, it's not a negative y, the y equals 0. So when we go to find, and this is going to be important for us from now on. So whenever we want an x-intercept, what we're going to do is we're going to plug in y equals 0, okay? And basically the same thought process happens for the y-intercepts. That's a spot where we're going to cross the y-axis, right? Okay, so whenever I do that, I see, oh, the y value, again, it could be a positive y, it could be a negative y, it could be a 0, but for sure the x value equals 0 there, right? That's where I'm crossing that point. So that's the way you find these things. When you want x-intercepts, you're going to plug in 0 for y. And whenever I want a y-intercept, I'm going to plug in 0 for x. Okay, so that's our process. That's what we're looking at. All right, so let's do that. Whenever, and remember that my original function was 3x plus 2y equals 6. So I'm going to plug in 0 for y. It's going to be 3x plus 2. Instead of y, I'm putting in a 0 equals 6, right? Okay, so anything times 0 is 0. That goes away. This is 3x plus 0, but I can just say 3x, right? 3x equals 6. And now going back to solving for x, solving these linear equations, I divide by 3 on both sides. The 3's go away there. That's just a 1x. But on the right-hand side, 6 divided by 3 is a 2. Okay. So this actually equates to a coordinate pair or a point, which is x equals 2, y equals 0. Okay, so this is important for us as we move forward. You're either going to have to write x equals 2, or you're going to have to write the point 2 comma 0. Okay, if you just say 2 and give that to me as an answer, I don't know what you're trying to tell me. Okay, so you have to be explicit here. You have to somehow tell me this is the point where the x is 2, okay? Or this is the point where the x is 2 and the y was a 0, okay? Because we plugged it in that way. We forced it, right? Okay, so that's kind of the process for this. You're going to have to be careful about it. To tell me for sure. I get a lot of students that just say 2, and I'm like, well, what is 2? What do you mean 2? Okay, so tell me, use your words, use your symbols in this case. All right, for the y-intercepts, we said plug in 0 for x. So it's 3 times 0 plus 2y equals 6. So the 3 times the 0, again, that's going to be a 0. I've got 2y equals 6. Again, to get the y by itself, you divide by 2, divide by 2. Oh, that's the pen that's trying to die on me. Sorry, I threw it away. And that gives me, these guys go away, y equals 3. Okay, so again, tell me the y equals 3, or you can give me the point 0 comma 3. And that tells me, hey, I plugged in 0 for x and I got out 3 for the y. Okay, so up here on my graph, just so we can see what's going on, I have the point 2, 0, right? That was my x-intercept down here. And I have the point 0, 3. And that was my y-intercept up there. And so now I have 2 points that are solutions on this graph, okay? A solution is some spot where this is a true statement. So again, plug it in. 0 times 3 is 0. 2 times 3 is 6. Does 6 equal 6? Yep, that guy works. 2 times 3 is 6. Yep, plus 0 times 2. 6 equals 6. Yep, that guy works. Okay, so those are both solutions to this thing, which means I have 2 points on this graph, and if I wanted to draw it, For a linear equation, 2 points makes a straight line. 2 points is fine. These are both x to the first, y to the first. They both have exponents of a 1. So these are not going to be weird curves or anything like that. We'll get into the curves later. Okay. But for our purposes, we have 2 points, our intercepts, x-intercept, y-intercept, and we put them up there. And that's what my graph is going to look like. All right, I hope that kind of makes sense. If you need to pause it, go back and watch so that you know you got what's going on here. Okay, so that gives us a basic idea of what's going on here with these linear equations that we're working with. Most of them are going to be linear equations in this section. Later, we'll get into the quadratics and stuff like that. So we need 2 different equations or formulas to work with. And on an exam, these should be provided for you, but it helps if every time you work one of these problems, if you will write these formulas down, you will memorize them very quickly. Okay, so that's what I used to do, is just every time I went to go do it, I'd write it down and I would know, okay, I'm good. All right, the slope intercept form of a line. Okay, so y equals mx plus b. Many of you have seen this before. The reason it's called slope intercept is because we very clearly have the m here. That is my slope. And this b guy back here at the back, that is going to be my y-intercept. Okay, which we just saw how to find one of those. So we should be good to go on both of these. The slope might be a weird thing for us, but we'll see. The thing about this is, in order for it to be in this form of the line, in order for me to pull out, just boom, there's the slope, there's the y-intercept. It has to be in this form of the line. So it has to say y equals mx plus b, or be in that format, okay? The one that we've got, that we've been working with, is 3x plus 2y, right? Equals 6. So just to continue with that one so we can see it in this format, I go, okay, I need the y by itself in order for it to look like this. So I'm going to subtract 3x from both sides. This guy will certainly go away. 2y equals 6 minus 3x. And then I still need to get the y completely by itself. So it's being multiplied by 2. I'm going to divide by 2. I'm going to divide everything by 2, and we'll go from there. This guy goes away. Let me keep this down for a second. Sorry. Y equals, I'm going to rearrange this so the x is in front. Negative 3 halves x. Okay, so remember that your coefficient can all be in the front. It doesn't have to be written as a fraction. And then this is a positive 6 over 2, so plus 3. And I look at that guy and I say, okay, this is in that slope intercept form. So I should be able to just pick things out. Okay, here we go. M equals negative 3 halves. Okay, that's my slope. Absolutely. And B equals 3. That's my y-intercept. Okay, so let's take a look real quickly at our graph that I had a minute ago. What we're seeing here is the y-intercept should be at y equals 3. There it is. Okay, and the slope is down 3 over 2. Okay, so we'll talk about more about slope in just a second. It's rise over run, right? So if I start here at the y-intercept and go down 3, and then to the right 2 over 2, okay, because 2 to the right is the positive direction, okay, then we see down 3 over 2. Sure enough, I hit that other point, which is awesome, okay? So this is definitely the same equation we've been working with. It just is in a different format. All right, so we know we are good. All right, so that is what the slope-intercept form of the line looks like. The nice thing with this is you can just kind of pick stuff out and be like, oh, there's my slope, there's my y-intercept. So let me just give you one that's in this format, and you can work with it real quickly. I want you to go ahead, pick out the slope, pick out the y-intercept, and graph it. Okay, so y equals 1/2 x minus 5. Okay, that's my new example. I want the slope, the intercept, and a graph. The y-intercept, I should say. Okay. So hopefully it's pretty fast for you. You just go, oh, the slope is m equals 1/2, no problem. Okay. The y-intercept may be a little more tricky. Look here. It's a b equals -5, right? So that negative sign goes with it, which is good. And then when I want to do the graph, I'm going to come over here and I've got the x-axis and the y-axis. And I'm going to start at the y-intercept, which is here, -1, 2, 3, 4, 5. You can fill that in if you want to. I don't normally fill in my scale. I normally mark it off and count it and then mark wherever I'm headed, okay? But there's definitely a solution to this graph. It's the y-intercept right there, right? And it says slope equals 1/2, okay? So again, m equals 1/2. We're going to talk a little bit more about this, okay? Many of us know that slope is rise over run, right? Okay. You might have heard it's the change in the y's divided by the change in the x's. And if you're really, really on that calculus path, you might have seen delta y over delta x, where delta means change in this case. Okay, so either way, any way you want to look at this, you're doing rise over run. So from this point, I'm going to go up 1 and over 2, and I'll have another solution for my graph. Okay, so this is the point 0, -5. This is going to be the point 2, -4, because it's up 1 over 2. So you can find all kinds of points, and that's not the only one I can go. I can go up 1 over 2 more. Okay, up 1 over 2 more, and that looks like 3. I'm sorry, -3, 4. Oh, no. I'm so sorry. I'm doing this backwards. 4, -3. Let me get them in the right order. Your X goes first. It's alphabetical order. X's and then Y's. There we have it. Okay, so I knew something looked weird. So now I have 3 points, and hopefully they're all pretty much in a straight line. I'm not an artist. You'll hear me say that throughout the semester probably. So hopefully it looks pretty good. But you're going to have that look at it whenever you're saying, oh, okay, I'm looking for rise over run. Okay. We also have a slope formula. Okay. That again, you will hopefully memorize very quickly by writing it over and over and over again multiple times, but it goes like this. M equals y2 minus y1 over x2 minus x1, where you're going to have some points, x1, y1, and x2, y2. And it doesn't matter which of your points you call the first guy and which of your points you call the second guy, but the ones stay in the same point and the twos stay in the same point. So if this is my x, my first x, then this is my first y. Okay, so hopefully that makes sense. All right, so this formula will come in play. For right now, I'm just using rise over run, but we're going to see this as we work on through. So yay. All right, so let us do another example. How about, the example I had was very similar to that example. So I'd like to not be very similar to that example. So let me make one up and hopefully we get decent numbers out of it. Okay, how about 4x minus 3y equals 12. Let's go with that one. That's my new example. Okay, and so the directions I'm going to have for this one are, we're going to work with it in several ways. So first, let's find your x and your y intercepts. Find x-intercepts and y-intercepts. And we'll graph it using that method. Okay, that's the first way. And then we'll use that slope-intercept form that we just found, and we'll deal with that. Okay, so remind me, if you put in an x-intercept, you're going to get that by plugging in y equals 0. It's always the opposite variable. So if I want the x-intercept, I plug in y equals 0. If I want the y-intercept, I plug in x equals 0. Okay, so 4x minus 3 times 0 equals 12. That's going to go away. 4x equals 12. And toward the end, we're going to divide both sides by 4. And x equals 3, right? So this point is 3, 0. The x is a 3. The y is a 0 because we plugged in a 0. We made it be that way, right? Okay. So on the other side here, let's do y-intercept. And as a reminder, it's x equals 0. So we plug in x equals 0. Okay. 4 times 0, negative 3y equals 12. Okay, and again, to get that y by itself, I'm going to divide by negative 3 here. So those will go away, and I get y equals negative 4. Okay, so this point is I put in x equals 0 and I got out y equals negative 4. And just go ahead and start practicing this notation. Either you tell me x equals 3 or you give me the point. I actually prefer the points just because that way we know, oh, we put in y equals 0 here. Oh, we put in x equals 0 here. That way you get the whole entire picture of that point and what it looks like. Okay, so here we go. We've got a graph. So we found the x-intercept, the y-intercept. We're going to graph x and y. And now I say, oh, I need the point 3, 0. That's right here. And I need the point 0, negative 4, which is down here. All right, so there's that guy. Whoop, just like this. Hopefully it's just like that, or pretty close. You get the picture. All right, so that's what this guy's graph looks like, and that is using the x-intercept and the y-intercept, okay? But I should be able to solve this any way I want to and then graph and still basically get the same picture. So let's see if we can do it the other method. So we're still going to use the same equation. 4x minus 3y equals 12, but we're going to use find the slope-intercept form of the line. And graph. And you can do either method you prefer unless, like in the homework, it might say find the slope, intercept, form of the line, and graph. So if it says that and you do the intercept method, the x-intercept, y-intercept, then you're not going to get full credit, right? So same thing on a test. So you need to do what it's telling me to do. Slope intercept form of the line. Hopefully you remember that. That's y equals mx plus b. We just showed it a minute ago. I'm going to get the y by itself. Negative 3y equals 12. And I'm going to get rid of this 4x. And the way I do that is by subtracting 4x. Those go away and subtracting 4x. Okay. So I've got 12 minus 4x. Okay. And then I want the y by itself. So I'm going to divide by negative 3. This goes away and I get y equals 12 over negative 3 is negative 4. And then a negative over a negative is a positive 4/3 x. Okay. All I did was split the denominator so that each of them gets their own denominator because I realized I needed in y equals mx plus b format. So I don't want them to share a denominator, if that makes sense. Rearranging it just slightly, put the x in front. I've got this y equals mx plus b format, right? So we are good. All right. So for this guy, I see the slope is 4 over 3, right? It's right there. And the y-intercept, the b, is negative 4. Hey, hang on a minute. We already had that, right? So, because we found the y-intercept the long way earlier, 0, negative 4. So that should confirm, hey, we got the right number. Okay, so in order to graph, and I'm going to do this at the same spot, but I'm going to use my pink to do it. I find my y-intercept, put my point. Okay, there it is. And then I do the slope. So it's going to be rise 4, run 3. And both of those are ending up positive, right? Because it was a negative over a negative was a positive. Okay. That's what happened there. So rise 4, run 3. So up 4, 1, 2, 3, 4, run 3. 1, 2, 3. Sure enough, look at that. I get those same 2 points. So for sure, this is the correct graph of the line, right? So we did it 2 different ways. We got the same answer. We should be good. Okay. I like it. And we've got the graph. So I feel like we're good to go there. See what else we got in here. Okay, let's take a look at that slope formula. So again, just so that everybody's on the same page, we've got the slope formula. M equals y2 minus y1 over x2 minus x1. And your examples are going to run along the lines of something like this, okay? Find the slope between the 2 points. Okay, and they're just going to give me a couple of points. So I've got negative 2 comma 4, and I've got 3 comma 4. All right. So again, it doesn't matter which point I pick as my first one. I usually say, hey, you're 1, you're 2. Occasionally people will pick them in a certain order just because they don't want to end up with negative numbers or something like that. But I'm just going to pick them just like that. So I'm going to say M equals, okay, and it's y2 minus y1. So 4 minus y1 is 4. Okay. And on the bottom, I've got 3 minus, so it's x2 minus x1, 3 minus a negative 2. Now, 2 things are happening with this, and I want to make sure we get both of them, okay? The first thing is 4 minus 4 is 0 on top, okay? But the second thing is down here on the bottom, I've got 3 minus a negative 2. And hopefully you remember a minus and a negative, or it's a negative times a negative, that makes a positive, right? Okay, so on bottom, I've got 3 plus 2, and that's a 5. In this case, it really doesn't matter too much because I get 0 on top, and 0 divided by any number is just a 0. So you can think of it this way. If I am trying to split up cookies and I say, hey, I'm going to share my cookies with you, with all 5 of you people. And then I look down and somebody stole my cookies. So I have 0 cookies. How many do each of us get? Well, each of us gets 0 cookies, right? Because I don't have any cookies to share now. Okay. So I can have really good intentions of sharing with 5 people, but there's no cookies, so nobody gets any cookies. Okay. So that's the idea for 0 on top, you get a 0. Okay. Let's try a different example. Negative 2, 4, and 0, negative 4. Okay. So we're going to do the same thing. Slope equals, it's y2 minus y1. Again, picking this guy as my x2, y2, x1, y1. You don't have to label them all the time. I do at the beginning just so everybody's comfortable with where did I get that number from. So y2, -4, minus y1 is a 4, all over x2 is 0, minus, again, this is a -2. So again, 0 minus a negative, that's going to be positive, right? A negative and a negative is a positive. On top, though, I've got -4 minus 4. Well, that's a -8, so be careful with that. I go down 4, and then I go farther -8 total, okay? And then I've got 0 plus 2, which is just a 2. So this guy reduces very nicely. My slope is -4, right? Okay. All right. And then one more of these, and then we'll talk about what each of them means. What if I had -1, 5, -1, -2? Okay. So real quickly on your own, plug that into the formula, see what you get, and then if you're not sure, it's okay because this one's a little bit weird. We'll talk about the interpreting the results. So pause me if you need to. Okay, whether you pause me or not, I have -2 minus 5 over -1 minus a -1. Okay, and remember that the minuses there are in the formula. They're both y2 minus y1 on top, x2 minus x1 on the bottom. So these minuses are in the formula. This negative is because it's a -1. And I get -7 over, this is going to be plus, -1 plus 1 is 0. Okay, so hopefully everybody realizes this guy is undefined. If you're not sure, you can punch him on your calculator. And where's my calculator? I'm sorry. I moved my calculator to a weird spot. Okay, so you can punch that on your calculator, -7 divided by 0, and it says, hey, you've got an error. You're trying to divide by 0. And that's actually going to be a very common theme for us all the way through this course. So just double, triple check. You cannot divide by 0. It's not going away. That's called a domain issue. You cannot divide by 0. Okay, so that is undefined always, and there's very few times that I'll tell you always in this class, but that's one of them. You cannot divide by 0, not never, and that's always the case. Okay, so here's what we got. On the last graph that we had, we had a positive slope. If you'll remember, m was 4/3. That's a positive. And we always read our graphs from left to right. So that is like I'm going up to the right. Okay, I'm rising to the right. That's the way we say it. Okay, we've got one where we got a 0 for our slope. And this one, I had a student one time. This one is like a horizontal line. And they said, well, it's kind of like the person's laying down and they're sleeping. 0, 0, 0, 0 coming out of their head. Okay, so it's a horizontal line. That's not my example. That was a student of mine's example. And we didn't graph this one, but if we did, it would look something like this coming down. Okay, actually it goes through 0, -4, so it's something like that. Sorry. But it looks something like that, and the idea here is that the slope is going down, or this is a decrease, negative slope. Or sometimes we say it's falling to the right. Positive slopes are rising, negative slopes are falling. And this one is undefined, and these guys go along with vertical lines or straight up and down. Okay, so you might have a horizontal, you might have a vertical, or you might have something where you're undefined. Okay, so my example is always I'm driving a Jeep. Okay, This is my concept. Okay. If I'm just going along on a flat line and I want to talk about the slope or the steepness, or you might hear it called the grade, okay, of the road, okay, this is a zero slope. There, it's flat, right? Nothing's happening here. It's not going up, it's not going down, it's just sitting there. Okay. If I then come up to a road. It's kind of steep. Maybe it's switchbacks or something like that. But I'm in my Jeep, so I'm going up. Well, that's okay. I can do this, right? No problem. Positive slope. Okay. Maybe I get to the top and I flatten out again for a little while. Again, that's a zero slope. It's flat or a horizontal line. That's what we call it. No problem. My Jeep can handle that. And then I'm coming down. Okay. That's downhill, right? Okay. It's a negative slope. Okay. This one was uphill. This one's downhill. A negative slope. No problem. We can do all of those things. Okay. Maybe I go for a little bit longer flat, and then suddenly I come up to the face of a cliff. Okay, this is like a cliff here. Okay, and it is straight vertical up and down, right? Vertical line. Okay, can my Jeep do that? No, Dr. Webster, your Jeep can't do that. That's what I hear in my head, just FYI. If you were in a face to face class, I would expect you to answer that question. Okay, my Jeep cannot do this. So this is undefined for my Jeep. Okay, or you cannot do it. Okay, undefined, no solution, all those things. My Jeep cannot do this. I don't have a solution for this cliffside. Okay, maybe you, I don't know, get out your rappelling equipment and go cliff climbing or rock climbing or something, but I cannot drive my Jeep up the side of that thing. All right, so that's what's going on with that. All right. So that is how I view slope. It's like I'm driving on a road, and sometimes I go uphill and sometimes I go downhill. Sometimes it's very flat, like out in West Texas. Okay, I might be able to just let the car drive itself, but on that cliff, vertical line, this is vertical, it is undefined. Okay. So that is the concept for me of slope. All right. Okay, we got to get one more formula in here, and then we'll do a little practice. We'll be done with this section. So here we go. All right. Um, here's what I want you to do. We have 2 points. Find slope. And then we will talk about how we're going to write the equation of the graph, or the equation of the line. Okay, my 2 points are 2, -3, and 4, +3. So pause me for a second. Go ahead and find the slope. Use your formula. Again, write it over and over and over again. And sooner or later, you'll get to where it's memorized. Pause. I'm going to do this problem real quickly. Hopefully you were able to do that problem. I work it out and I say, oh, my slope is 3. Okay. So I was given 2 points. First, I found the slope, but now they ask me something like this. Write the equation of a line. Equation of a line that goes through these 2 points. Okay, that's what I want to do. And so I found m equals 3. That's great. And if I was able to use the formula that I already know. Remember, recall, y equals mx plus b. I have the m, but I would need the b, right? And just given these 2 points, I don't really have a way of coming up with b just all by themselves, okay? So what I need to do is I need to go through and do a different formula, okay? So that's where my point slope formula is going to come in. Okay. And basically, what we do with this is it is just this slope formula rearranged slightly. So if I multiplied both sides by the denominator here, I would get y2 minus y1 equals m times x2 minus x1. Okay, that's just rearranging this. And that's all we're doing in any of these problems with the different forms of the line is we're just rearranging them, right? So we go from the slope, we have this. All right. But we want to do this with just 1 point. So it's going to be y minus y1 equals m times x minus x1. You can keep the 2's in there if you want to, but this is the actual formula. Okay, y minus y1 equals m times x minus x1. And the reason why we do it that way is because you can use this formula just using the slope and 1 point. Okay, and it doesn't matter which point we use. So we will end up getting the equation of the line with this. So let's see. I've been calling this guy x1, so let's keep on doing that. So I'll use this point, but sometimes people want to rearrange and use different points, again, mainly based on the negatives. So y minus, I'm going to be doing -3 equals m. Oh, I know the m, that was 3, times x minus, and the x that I'm using is a 2. Okay, where again, remember this x and this y are variables, so we're not plugging into them. That's one reason why they dump the 2's. Okay, so we're not plugging into those. Those are going to be variables. We're just going to keep them along for the ride. Okay, so let's see what we can do. This is y plus 3, and I'm going to distribute this 3 through, so it equals 3x minus 6. And now I say, hey, get that y completely by itself. So I'm going to subtract 3 from both sides. Okay. This left-hand side is just y equals 3x. -6 minus 3 is minus 9. 3x minus 9. So there is my equation of the line. And we know, hey, our slope is 3. And here, our b, our y-intercept, is -9. So that's how we manage to get our y-intercept whenever we're like, oh, what are we doing here? Okay, so we just had 2 points. We find the slope, and then we plug that and one of the point into this formula. Okay, so plug in the slope and 1 point, and then solve for y. Okay, that's the process I just did. Okay, so you can see that and you just get your answer. No worries. All right. Okay, so you might have some different ways that they give these problems. So just to make sure you're all prepared for doing your homework, here's an example that says, write the equation of the line with m equals 1/2 and y-intercept -1. Oh, well, that's pretty nice of them. They're giving me a slope and the y-intercept. I can use my y-intercept formula, right? So y equals the m times the x plus the b. I just need to substitute in there. So I can do that. The m is 1/2 and the y-intercept is -1. So if you wanted to clean that up just slightly, you could say y equals 1/2 x plus and a negative. Positive times a negative is a negative. -1. So sometimes they'll give you fairly straightforward problems like that where all I have to do is plug in and that is lovely. Okay, but sometimes it's like, nope, this is not happening. Okay, so I have to do other stuff. So let's see. I think one more example and then I'll just set you loose. Oh no. Yeah, maybe two more examples. We'll see. All right, and then I'll just set you loose on the homework so that you can do it. Okay, so maybe one. We'll see. Okay, my example says write the equation of the line. All of these are lines with slope 2/3, and that goes through the point 6, -2. Okay. So we're going to write that equation of a line. All right. Well, I look at this and I say, hey, I have the slope and I have a point. So I'm going to use the point slope formula. Again, just so we're in the habit of writing them, y minus y1 equals m times x minus x1. And I'm just going to plug the stuff in where it goes. So y minus the y1 here is a -2. M equals M times, which is 2/3, times X minus the X1 here is a 6. Okay, so hopefully you can plug those things in pretty well. If you need to, you can kind of come off to the side and make yourself a little side notation. M is 2/3, X1 is 6, Y1 is -2. So that you know, oh, these are the things I'm plugging in. That's what I've got here and here and here. You don't have to write that, but if you're struggling a little bit, feel free to write that. Okay. Take an extra, what did that take me? Like 2 or 3 seconds to do. So sometimes just a little bit of extra work is worth it so that you're like, oh, I got this. Okay. Y minus a -2, and not minus and a negative is a +2 equals 2/3 x and then 2/3 times -6. Remember that this -6 is really everything can be written over 1, and I'm distributing, right? So a positive times a negative is going to be negative, and the way we multiply fractions is top times top, so 6 times 2 is 12, and bottom times bottom, so that's 3 times 1 is 3, okay? But I know that I can make that a little bit nicer. 12 over 3 is going to be 4, right? And then the last thing, so I'll do that in a second, is I'm going to subtract the 2 because I want the y completely by itself, right? All right, so I've got y equals 2/3 x. This is -4, -2. That's going to be a -6. All right. So hopefully that makes sense. If you're not sure what I did there, I took 3 and divided it into the 12 and made that a 4 over 1. All right. Hang on just a second while I look at my notes. I think that's about all I've got on this section. So let's do a word problem and make sure we're good to go there. And then you can do this homework for graphs and lines. All right. We have a company and we're going to make skateboards. Okay. And as I go through, I realize that, hey, I have somebody in my accounting department or somewhere up in finance has figured out I have a fixed cost of $300 per day. Okay. And I have total costs of $4,300 per day when I make 100 skateboards. Okay, so that's the information we're getting from our back office that tells us all this, what we're doing. Okay, so the problem is going to say something like find C of X, the cost function, right? So let's see, how did that cost function thing work? I took the fixed costs and I took the variable costs. In this case, I need to find the difference between them. So what I would like is the average between these or the slope. Okay, so I'd like to see what's happening in between these things. So let's look at this for just a minute. Fixed cost is cost of things no matter what. Even if I make no skateboards for sure, it's going to cost me $300 per day. So again, I'm letting X equal the number of skateboards that we're producing here. Okay, so if I make none, I still have to pay $300. Maybe that's rent or something like that. But this tells me, hey, when you made 100, now that's still the number of skateboards, right? So when we made 100, X is 100, our cost was 4,300. Okay. So what I'm seeing here is I need a function, I need an equation here, the cost equation, and I've got, it will be a function, just FYI, we're just not there yet. I've got 2 points. Okay, so can I write a cost equation using those two things? And the answer is yes, we know how to do this. Okay, so again, m equals y2 minus y1 over x2 minus x1. Well, I'm going to come right here. I'm going to pick this one for my x2 because that way I can do 4,300 minus 300 on my y values, right? On the top, that'll give me a positive number. And on bottom, I can do 100 minus 0, and again, that'll give me a positive number. So this is 4,000 divided by 100. I'm getting rid of 2 zeros there. You can punch it on your calculator if you need to. But that's a 40. So that slope here is going to be 40, or the change between these 2 points is a 40, right? And that's positive. So that's a positive slope, no problem. Oh, excuse me. And now I need to do the formula or the equation. And what I know is I've got 2 points here. Oops, sorry, 2 points, and I've got a slope. So I think I need to use the point slope form. I don't know my y-intercept, so I can't use slope intercept, right? So that's y minus y1, m times x minus x1. And that's y minus, pick one. I don't care which one. I actually think this is smaller numbers, so I'm going to go with him. So y minus 300 equals, the slope is 40, times x minus, when I use 300, that was a 0, right? Okay. So when you plug that guy in and you distribute here, well, the nice thing is 40 times 0 is 0, right? So that's just going to be 40x. Y minus 300 equals 40x. You could write plus 0, but I don't really need it. And now to get rid of this 300, I'm going to add 300. Those go away. Excuse me, I'm out of space. Y equals 40x plus 300. Okay. Or that's my cost function, right? So C of x 40x plus 300. And sure enough, realizing that, oh, I did have my y-intercept because I had a point, right? X, Y, 0, 300. So I actually could have just gone straight into y equals mx plus b. I just realized, but that's okay. It's a good practice for us, and we'll be okay. All right. I think that's it for now. I might have some other examples of applications, but we can do those on a different video. You should be good to go on this homework, and I will talk to you later. Thanks.